Let's begin. So, exercise 1C. Today we're going to talk about types of relations. Now, these are the dot points from your study design. So if you're following it, you can tick them off. Otherwise, you can look at these PowerPoints and tick them off. So these are covering dots, identification of key features of graphs. It's sort of a power function when we're talking about odd and even. And then in the graph section, obviously, you want to know every single one of these. I'm going to teach you composite functions later on, circular, exponential, and log. You've learnt already. Simple transformations, combinations, but today's more specifically in 1C is hybrid. So piecewise hybrid functions. Okay? And then in your key knowledge, just in case you didn't know what DP means, it means dot point. Dot point 1 and 5. So if you're looking through a study design, you can just count them. And those are the ones I've picked out. It's 1 and 5, that's what it's representing. And key knowledge, 1 and 5. Okay? So you want to know the properties of a function relation. That's pretty much the same as yesterday's, and this is also the same as yesterday's as well, talking about symmetry and equivalence in regards to odd and even. Okay? Now, these are your exam questions. You can refer back to it. These are the solutions I told you I'll put up every following session. So for 2 questions per exercise, there was exercise 1A yesterday and 1B. This is the first solution. You can look at it in your own time. So if you have questions, come and see me. Okay, I put up my timetable. You haven't checked Schoology. I put up my timetable on the very front page, so you can access that. There's a course outline on it as well, and it has today's session as well. Okay?
Just one sketching graph, should we always write the rule?
Yes, do it. Yeah, especially when there's multiple graphs. But in year 12, I would do everything as pedantic as I could be. Okay, even for these ones, I know the questions don't say it, but I would do it out of habit, where any axis-intercept I'd label in coordinates as well. Okay, I know it doesn't say, but it's always better to have a coordinate than not, because if they wanted it and you don't have it, you lose a mark. But if you have it, you don't lose a mark. Okay, so yeah, just in terms of labeling graphs, asymptotes, always label your equation asymptote, so don't just do a line and hope that having a 2 there is okay. No. The question said label each asymptote with its equation, so therefore you had to. Label all axis intercepts. You do. I would highly recommend that you would change that to 1, 0, and this one, oh, they didn't label it. Naughty. That should be -2. So 0, -2.
We need to draw the arrows as well.
Do you need to draw the arrows? Yes. Draw the arrows as well. I know you can just draw a line and they should be fine, but as a habit, change it to arrows so it indicates that you're continuing. If you want to end it or there's a restriction on your domain, that's when you use your closed or open circles. Okay? But otherwise, draw the arrows. Okay, so as you're drawing them, draw the arrows to indicate that it's approaching the asymptote or it's going into infinity. Okay? Label your function, label your asymptote, all your axis intercepts, make sure to label in coordinates. Okay, it doesn't hurt to put it in, but it does hurt if you don't put it in, right? And always label your asymptotes, the equation. I see that all the time. Every time I mark the sacs, I'll catch someone who doesn't label the asymptote, and they hope that's just fine. No, it's not fine. Okay, because the question specifically said with its equation, all right? And if you get this one wrong, if you wrote x equals 2, that's also wrong as well. Okay, it has to be y equals 2. It's your y line, not your x line. All right. Now, all the solutions are up there. Have a look at them, and those are the first 2. So for tomorrow's 1C, you can have a look at that as well. Okay, so I'll put on the answers for them, but just check through the PowerPoint. All right? Now, this is an old PowerPoint. Let me just mute that for a bit. Sorry. I totally forgot. There was a year where I had an aim to put as many sound effects as I can in every single slide. And I had, like theme songs. Every time you move a slide, it'd have a theme song and a transition. It took too much time, and kids were more engaged with the sound rather than the actual content, so I removed it from there. It's very old content. But anyways, same questions. Here we go. So what I want you to do is, recapping yesterday's session, we're going to talk about what is the difference between a relation and function, is the set of coordinates below a function or relation. So recapping, what is a function, what is a relation, how do you know? Write using set notation, interval notations, two different ways to illustrate the following. For A, you got f of x equals negative of root of x minus 2. What is its implied domain? What is the range of f of x? And what is the preimage and image mean? So for example, if you had g of 2 equals 10, which is your preimage, and which one is your image? It's a quick recap. If you don't know it, skip it, just have a go. We're going to give you 7 minutes and I'll describe each one before we start this session again and talk about types of functions and relations. Again, recapping yesterday's session, and I want you to spend this session doing 1B. Okay, remember, don't do all the questions. You can if you want. Do them until you understand what I wanted you to know. What is a function? What is a relation? Types of relations. That's what you want to know. Okay, difference between vertical line, horizontal line. That's what I want you to understand. Okay? Once you understand that, move on to C. So don't do all questions unless you really want to. Do what you need to understand the material. Study smart, don't study hard. Okay? Let's go. 7 minutes. Just quickly checking the roll. Sebi, Pius, Layla. And it's here. Amir, David, Percy, Adam, Frank, Quinn, Stephen, Alice, Karen, Luke, Jack, Daniela, Josh, absent, Neve, Jonathan, Janset, Amy Van, not here, Gary, Bree, Rex, alright, thank you, and Stephen. Is the other name pronounced as Stephen Lau, or is it Stephen Lau? Stephen. Alright. Thank you. Is it hands up or? Okay. For question 4, you can use the calculator to sketch it if you want. Now 3 minutes. So I'm just quickly checking. Cool. One more minute.
I was going to do the answers equally correct, or is there one that's like I guess that would be the better way to write it. Is that
No, absolutely not. You generally prefer interval
yeah, for these ones, when it's like x and 4 different, do you just assume that 4 is like just a line, like y equals 4? Is that what that means?
Yes, they're saying that the coordinates y is always 4 and x can be any. So that would be a horizontal line as long as it is 4. Alright, let's go through the answers. What is the difference between... For who? Murray? Is there Murray in this class? No, I think it's the wrong class. No, we don't have a Murray. Alright, what is the difference between a relation and a function? Can you please describe to me in your own words, Layla? What is the difference between a relation and a function? Describe to me in your own words. Perfect. A relation is just a set of coordinates. So you just need to understand a group of coordinates like the one I gave you over here. Okay, so this one over here, that's a set of coordinates. If you plot it and you draw a line through it in any way, that's called a relation. Okay, we don't know how to draw them, it's just a set of coordinates. When you have a set of coordinates where it follows a particular property, we call that a function. Now, what is that particular property? And yesterday I was trying to describe it. I was saying that, imagine it's a machine. A function is only when you spit out one unique y value. Okay, so what I'm really saying is, in a set of coordinates, there is no repetition in your x values. Okay, because if there's repetition in x values, that means you have repeated y's, or you have two y values. Okay, two different y values. So what I'm saying is the classic example of a square root function. If this was 4, and square root of 4 is 2, or negative 2, you see the coordinates here would be 4, 2, and 4, negative 2. This is not a function because you have two separate y values for one input of x. Meaning in this machine, if I put in an x value that's 4, it spits out two values, that is negative 2 and 2 if the function was a root x. That's why it's not a function. So a function is a relation, but a specific type of relation. It's such that the coordinates follow the idea that there is only one unique y value. When you have two y values, then it's not a function, it's a relation. So when you're looking at coordinates, what are you looking for? Repeated x values. I'm going to highlight it again, repeated x values. And it clearly shows you this is not a function. Okay, and one way to remember that is, remember a square root function, you only drew the upper half. You only drew this. You never drew the bottom half. This was positive root. That was a positive root x, and that was a negative root x, is how you learnt it last year. Okay, so this would be a square root relation, but if you want a square root function, you either have a positive square root function or a negative square root function. That's the difference between a relation and a function. Okay? So, leading on to the next one, is the set of coordinates below a function or a relation? All you had to look for was whether there's a repetition in your x coordinates. And so we have a look at the x coordinates, and you can see that you got negative 1, 0, 1, 2, 3. Doesn't matter if you have repeated y values. If you actually plot this and sketch it, it's just a straight line. Y values are always 4. It's a horizontal straight line. Y is always 4, and your x's change. So if I draw the picture, remember it's all about visualization. The more you can visualize the graph, this is a horizontal line at 4, clearly there's one y value for every x value. Okay, so that is a function. It's a linear function. Okay? So yes, this is a function, that is a function. Now using set notations or interval notations, in case you're confused by what the two is, interval notation is something like, from 0 to infinity. That's called interval. Set notation is like saying R plus. Okay, that's set notation. Interval notation is the other way. Now you can use both, it doesn't matter. Okay, I asked you to use two different ways. Give me one way that you came up to illustrate that number line. Can I please have Percy?
R plus.
R plus.
Excluded 5.
Excluding 5. Like that? What are we missing? What kind of bracket? the braces bracket or curly brackets, okay? That is incorrect if you wrote it like that. The proper way to write it, you have your braces. Remember, the braces are used to indicate an individual term or list of individual terms, okay? Because I want to say just the number 5, you write the squiggly brackets or curly brackets or braces to indicate there's just a 5, okay? Backslash is how you say you exclude, or otherwise I backslap you, okay? So remember, backslap, backslash, okay? So that's one way. Give me another way to illustrate this number line. Can I please have Jonathan?
X is an element of 0 to infinity, open brackets.
X is an element of
0,
0 to infinity,
open brackets, so not including,
like that.
and backslash, braces, 5.
Perfect. Absolutely nothing wrong with that too. Okay, the X is to tell it a domain. You could easily do that for the range as well. There's nothing wrong with that. Okay, you can also do, if we're just using interval notation only, we could say 0 to 5, union 5 to infinity. And that's perfectly fine too. Okay, so there's a lot of ways to explain it, but what I'm trying to teach you, which is exercise 1A, how to use the language. Okay, so they're all the same. They're all the same. It's up to you how you want to use them. Okay, so I used a bit of union. You can use intersection if you want as well. Okay, so you can sort of say R plus and exclude the intersection of this interval and that interval or something like that. It's complicated, but you don't have to do it that way. This is probably the easiest way to do it. You can do it either way. Okay, so that's question 3. Now question 4, remember I said the hardest thing about methods is really just to visualize. The better you are at visualizing the graph, the easier it is to answer every one of these questions. Okay, so for now, if you had trouble sketching this graph, the square root function, you can use your calculator. Later on, I expect you to do it without using calculator. But quickly, that's a translation to the right by 2, and it's a reflection in your x-axis, so it should look something like, where's my blue? It should move to the right by 2, and it's a reflection, so it should look something like that. Okay, so that's my graph, and answering the question is really easy now. What is its implied domain? From here, once you can sketch the graph, you can see domain is 2.
Can you not have 0 because then you get 0 minus 2 is negative?
0. So if you have 0, 0 minus 2 is negative 2, but you can't square root a negative 2.
Isn't it like up 2 rather than?
So you're saying,
Is the last point, like, isn't the endpoint up 2? Because you have 2, you have x plus. Wait, no. Okay.
alright, cool. Cool, so it's right by 2 and inverse reflection. So answering the question, implied domain, once you've got the graph, it's very easy to answer. That's why in methods, the better you are at visualizing, the easier it is to get it right. Okay, so my recommendation for your SACs and all the applications, draw it. It doesn't hurt to visualize, learn to draw them. Okay, so looking at the domain, clearly it's from 2 to infinity. Okay, and your range is negative infinity to 0. Okay, or you can just say R negative union 0 if you wanted to. Okay, or that's fine as well. Okay, Y is an element, Y is an element. Up to you. But the point is, I'm trying to illustrate that sketch the graph. Sketch the graph makes it easier. So for now, if you can't do it in your head, do it on a calculator. Yep.
For the domain, can you do R plus excluding 1?
No, because then if you do it excluding from an interval, because if you exclude 1, can you have 1.5? Can you have 1.99? So you'd have to exclude. You can say R plus and then exclude, I guess, 0 to 2. Yeah. And that should include the 2 as well. And yeah, that should be fine from an interval. Yeah. Okay. All right, any questions on that before I get into what does the pre-image and image mean? All good? All right, pre-image is what you put into the machine. So remember, this was my machine. This is called the pre-image. This is called the image, so the output. Okay, so input, what am I putting into the machine? It's my domain. And so in this case, 2 is my pre-image. And what I get out of it after I put into the machine, and g of 2, whatever g function does, it could square it, square root, plus, minus, I don't care. Whatever the function is, it gives me 10. That is my image, or technically y value. Okay, so pre-image is the x value, or your domain. Image is your y value, or your range. Okay, so there's the terminologies from yesterday. And finally, now we're moving on to today's session, which is types of relations, which I hit on yesterday as well, but just to recap so that you can do your work. Okay? Let's have a look. Now, it says each of the following is the graph of a relation, and then state which other graphs are functions and which other graphs are one-to-one functions. And you can have many-to-one, you can have one-to-many, and many-to-many. Yeah? So the 4 types that you have were 1, which, oh, that's right, I can't write on this thing. Ugh. Oh no, it's there. How do I rub it off? Oh. It's not calibrated, so I can't figure out where it is. Don't worry, they'll do. Alright, so you have one-to-one. That's a type. You have many-to-one. You have one-to-many. And you have the 4th type, many-to-many. Okay? And remember, I tried to explain to you, they're just like your coordinates. You're saying for every 1x, there is 1y. For many x, there is 1y. For 1x, there are many y's. And for many x, there are many y's. Okay? That's one way to remember it. Another way to remember it as well is with your machine. What I'm saying for the first one is if I put 1x in, I get 1y. What's a typical example of that? A straight line equation. Because a straight line equation, for every x value, so let's say it's 2, I get 1y value. Okay, there's no other coordinates except for that one point. So this is an example of a 1x for 1y. So 1y, this is linear. An example of one-to-one. An example of a function where you put in many x's and you get 1y, so it's many x's for 1y, would be something like this. I'm saying, whoops, I'm going to put in this. I'm saying you can put multiple x's in, it doesn't matter x1, x2, x3, and you get 1y. A typical example is your square root, I mean not your square root, your hyperbola function. Why? Because in your hyperbola, if I sub in 2 and -2 and the function was x squared, clearly 2 squared gives you 4 and -2 squared also gives you 4. So what you can see there is I can put in x equals 2 or x equals -2 and I get y equals 4. So many x's to 1y. Okay, notice that as long as you get one y value, I told you from the beginning, a function is a relation such that you get one unique y value. That's why it's easy to tell which ones are functions. It's either one-to-one or many-to-one. These are functions. So these two are functions. These are two relations. Because you don't have one y, you've got many y's, many y's. So an example of these two, so this is a quadratic, this was a quadratic. This was a good example was a square root function relation. Okay, and a square root, if I just quickly draw that for you to see, that's your square root relation. Clearly for one x value, you get 2 y values. Okay? And that's in terms of the machine. I'm just saying when you put in 1x, you get 2 y's. That's a square root relation. And finally, many to many. What's an example of a many to many? Circle. Okay, circle in all directions. You can see that it crosses twice here. So for one x, you get two y's, but at the same time, two x's, you get one y as well. Okay, I mean two y's as well. So one y, you get two x's, and one x, you get two y's. That's why it's a many to many. All right, so that's a many to many, and then an example of that is the circle function. Those are your four types, and that's 1C. Easy? Okay, there's hybrid functions and odd and even, but I'm going to stop here. You can have time to go through 1B again. Make sure to consolidate that for me. Understanding of what a function is, what a relation is, what is domain and range, okay? And finally, the types of functions and relations, because that will help you to understand inverse functions, okay? Make sure you understand that. Go back to 1B if you haven't finished it. Do 1B and start on 1C. We'll start on these questions here. Okay, so identify for me, state which of the graphs are functions, state which of the graphs are one-to-one. Okay, you can use your vertical line test or horizontal line test as you wish. Again, I don't want you to memorize the line test. I want you to understand what the line test does. So you draw a vertical line and then you ask yourself, what does this test mean? What does it mean? That way you understand it. Don't memorize it. Okay? Don't memorize it. Learn it. Understand it. All right, I'll leave that that's it for today's session. Everyone's got the payment form for the competition? Yes? And if anyone didn't get competition papers, it's up here too. All right? Otherwise, if you have questions, come and ask me. And I'll have the video here and upload it for you guys as well.